What's up guys, it's James aka 304 Techman here, and nothing is more frustrating than running a print overnight and coming down in the morning just to see that it looks something like this. X-axis shifting is your worst friend, and it's something that can cause major issues for your print. In today's video, we'll be talking about bad quality, what X-axis shift looks like, why it's caused, and then a good quality of what your part should look like and how to fix it so that your printer is producing great quality parts. All right guys, so to jump right into it, we have a comparison side by side of good part versus a bad quality part in terms of X-axis shifting. Yes, I know you can see a few little hairs right there. We'll get into the refraction of that later. So here we have the bad quality part for X-axis shifting, and you can clearly see that the print has multiple shifts throughout the X-axis, and it just really didn't get a good base to print on. If you flip it over, you can actually see again that it tried to get a good base, maybe say 15 to 20 layers, but then as you continue in the print, it just became worse and worse. And this isn't even close to the original part, so this is not the kind of quality that you really want coming off your 3D printer. So here we have a good quality part for X-axis shifting, but geez zoy, look at the hairs on that fella. In terms of refraction, this is still a bad quality part, so make sure you check out our other video on how to fix any refraction or stringing issues. But back to X-axis shifting. Something that you can see is that this is a one solid part and there's no shifting at all in the X-axis. So now we're gonna jump over to the grind zone and talk to you guys about how you can fix your X-axis problems. All right guys, so before we get into any removing or loosening of the bolts or anything like that, three things real quick. First, just make sure that your Z-axis is up. I like to keep mine about 3/4 of the way up. This prevents any kind of dragging of the nozzle or any tools or anything you're using from scratching your actual bed, which you do not want that. Additionally, make sure that any cords like the LCD cords you have right here that are loose, make sure that when you're moving the printer at all that you don't snag them and they don't stretch or anything like that. I know you can normally have them tucked up on the side, but there's plastic parts I had were kind of damaged, so I ended up not using them. It's just something on the to-do list. And lastly, I like to have my printer off and unplugged, so you can see there's nothing in there. Anytime I do work, I like to have it unplugged. So to get right into it, I'm just gonna do a little turn so I can make it more accessible. And these 3 screws right here are the first step. So this is in general kind of the X-axis teardown. We are gonna pretty much loosen these screws and then manipulate this bearing right here so that it's a lot easier to get off with the belt being removed as well. So first is to loosen these 2 top screws enough to the point where they're actually not attached to the X-axis motor at all. It may take some trial and error just to make sure that they're fully detached. So once we have these 2 fully detached, you're then going to want to go to the bottom screw and loosen it. I would say maybe a good 3 full turns. That's just enough to where you can see that the motor needs to get loose. So right there, you can see the motor is pretty loose. That's a little looser than I like. You do not want the motor to fall while you're doing this repair, so I'm going to tighten it a little bit. And you can see I still have that wiggle room. As long as you have that wiggle room, that's all that matters. So once you have that done, the next thing to do is to take the X-axis itself actually and turn it just enough to where you can access these holes on the bearing, because we're going to have to loosen those. So we have that lined up now. It's very accessible to take our Allen wrench and loosen them from that side. I'm just going to switch over to the 1.5 Allen wrench on this tool. I don't have fingernails, so we're just going to pull it out like that. So now that I have that, I'm going to get up real quick and get a good angle to loosen this. And I'm going to loosen this fully. It could be very loose. You do not want these to come out. These are very small, easy to lose, very bad if you lose them. So we're going to shift the axis again to get access to the other screw on this. And we are going to turn that loose. So now real quick, you can see that this does slide. That's exactly what we want, but leave it on there for now. So now we're going to go to the back of the printer. Depending on how your printer is set up, you might want to give it a nice little turn to make it accessible. I still have filament attached that I did not want to mess with taking out of my multicolor, so I just left it on, but it's still out of the way, so it shouldn't be an issue. So take a pair of pliers, and you're basically going to want to put them right to the right of the extruder piece, plastic piece right there. I like to keep a hand there just to keep everything smooth. And this should pull off relatively easy. If you have to use a lot of force, then you're probably doing it wrong. And you don't want to stretch the band, stretch the belt at all, or damage any of the little grooves in there, because that's what actually runs on the bearing and pulls the x-axis left and right. So we have the pulley loosened now, and you're just going to want to pull it back and feed it through the top part of the bearing. So now it's off the bearing and it pulls right out. And we can still leave it in the middle section, but I'm just going to pull it through and give it some nice slack right there, and then I'm just going to kind of set it right here out of the way. So now that I have that loose, I'm going to go back to the front, and I'm now going to take off this bearing. So I'm just going to take it right off. And so, really the issue that was causing your x-axis to shift was basically the flat part of the motor shaft, which currently is all the way at the top, right there, was not properly aligned with the top screw. So you want it to be pretty flush. Like if it was to go on right now, that's how you would want your screw orientation. So to make it accessible and easy to put this on in the correct orientation, I'm just going to use my hand and give the x-axis motor shaft a few turns to where the flat part of the motor shaft is perpendicular to the left side, basically giving it a solid 90-degree angle. Once I've done that, I'm then going to take this bearing. So once I've done that, I'm going to take this bearing and align it to where the first top screw is going to be lined up on the left side. So right now I'm just going to have this part here. I'm going to take it. So my first screw is lined up with the left side, which should be the flat part of the motor shaft. And then my second screw should be directly beneath that. It should be to the left. And so I want to put this on in the correct orientation. And just get it on there in the general area and at first, and then you're going to want to maybe play with it a little just to make sure you get it right. Additionally, the distance between the back of the bearing and the front of the motor shaft, kind of like right where the motor shaft begins, according to the Prusa manual, you want it to be about 2.5 millimeters or 0.1 inches. So make sure you're pretty close in that ballpark range, because that can kind of cause some potential warping of the belt or other issues that you do not want to deal with. So once you check that measurement, you're now going to want to go back, get your multi-tool, and you're going to want to kind of get up close and personal with this one. And really, I like to kind of almost pinch the shaft, the bearing to the shaft to make sure having the right orientation. So right now I'm holding it in place. The top first screw that I'm going to screw in is correctly oriented in alignment with the motor shaft, and I feel pretty good about the angle it's at. So I am going to go ahead and tighten that. So once you have your first screw in place, you're going to want to then turn it clockwise so that the bottom screw is accessible. You might actually, with the multi-tool, I can very easily kind of get a good angle, and still a little awkward, but you can get some good leverage on it and just tighten it in place. If you don't have a multi-tool and you can't get that proper angle, then all you need to do is really just take a pair of pliers, kind of grab the end, and just give it a turn. That's it right there. And now you have your screw accessible on the left side. So we completed that. We're fairly confident with the positioning that it's on, and it should have about a 2.5 millimeter gap. I actually just want to know myself if it's right. Let's see how we're doing back there. Yeah, it looks fine. So everything's done with the bearing. It's tightened, should be good to go. We have the proper alignment with the screw and the actual flat top part of the motor shaft. So we're gonna work on putting the pulley back together now. And this can get very frustrating, so have some patience and do not get frustrated. You're not alone. All right, guys, so here we have the band. You can see it holds a little bit of form already, so it can be a little frustrating when you're going either underneath or over top of the bearing. But basically, you're just gonna take it and feed it right through this hole right there. Making sure that the grooves are up. You can readjust that when you get to the other side, but just as a good precautionary. So be very gentle as you pull these through. You don't want to damage any of the grooves.
So right here, we have some good tension. You know, we can check right away. You don't want to pull too hard to mess with any of the grooves, but that's all good. So now we can see we have a little bit of form there, and it's a little frustrating when you're putting back through because you're coming down into the hole like that, and it can hit these other grooves and kind of get stuck. So a quick trick that I like is to maintain some tension down here with one hand. With the other hand, feed it over top of the bearing into the hole. And when you do this, you want it to be about right there. You want it to be as farthest to your right as you can. So let's feed it through. Make sure you're getting it at least, you know, a little bit of the ways in there. And right away, you know, I can really feel the kind of tension there. Didn't get it through all the way. So this little trick is maintain tension on the bottom and then actually just pull. You can see right away, okay, it's coming out. Pull towards you and then just give it a quick grab. Slowly pull it through. Double check that you are aligned with the grooves on the bearing. And now you got the true tension, so we can see right away, okay, that's a lot better. So now we just need to put the back side of the belt into the piece on the extruder. We're on the back side now, and I'm gonna hold this with my left hand in place, the belt perfectly in place, and then remember, you want this motor to be decently loose. That's probably a little looser than I like, but it should be all right. The biggest thing, you don't want it to be too loose because you don't want your motor to fall backwards. So make sure it's into the left, just like that. So you want it to be up against this, really close to the black box, close as you can get. And then the next thing you want to do while maintaining that same tension in place is form a nice little loop like that. So that's my first loop, and wow, clearly you can see I'm not even close to getting it back to where I need to be. So I'll pull it forward a few grooves, a little bit closer. Let's see how we like that. Almost there. So I'll go up 3 more. Oh, so close. All right, it looks like that'll do it. So I'm gonna no, that's not gonna do it. I'm gonna do it one more. So once you get that point, you can see, you guys kind of use that as a good reference. That's pretty good quality right there to get it back on. So once I do that, I'm just gonna come a little further up, pinch it, and then just kind of push it back on. So I have it on, and now you're gonna want to take some pliers or something with the, you know, decent edge and kind of go in there and really just make sure it's fully in all the way and just get all the angles. You want it to be fully wrapped. Push that back, we'll get the bottom, the middle, and then you can see how that kind of is, it's really easy, that just sits right on top of each other with those teeth. And right here, you know, very, very, very loose. There's barely any tension there. And the reason why is because now with this axis, as you pull this back into place when you screw it in, and you see how much tension was there, it was enough to where my hand slid off. You can see there's a lot better tension there. Almost should be like you're playing a guitar, just like a string. And that's the kind of tension you want. So once you're comfortable with that, you know, I got it on my first try because I've done this a few times now, but you might have to play with actually getting that part of the belt in to where it is the correct amount of tension. We're gonna go ahead and move back to the front of the printer and put those screws in place. Keep this kind of in place. You don't want to pull too hard on the rods right here downward because you don't want it to start sliding. So as you're pulling on the back motor there, go ahead and just start to screw these screws into place. I got that one started, so it's good. Once you get one of the top ones in, the other one should directly line up. So now you can take your hand off. I've got them all in. I'm just gonna finish tightening them up, and then make sure you don't forget about that bottom screw that you loosened originally. Come back there, and it was a little loose, so just give it 1 or 2 turns. It should be good. And now you're gonna wanna, before you turn it back on and do any tests, just give it a quick turn, and really just make sure that your screw is lined up with the flat part. So I just turned it to, shaft is parallel on the left now, and you can see right away that screw is right there. So I'm just gonna give it a nice up close look. Feel really good about that quality. So I'm gonna go ahead and turn the printer on, and we're gonna just do a few different things to do a quick test and just make sure that our quality is good. Okay guys, so plug the printer back in, turned it on, regular screen, startup menu. So one of the quick ways to just do right away, first off the bat, is to go to your settings, move axis, and then your x-axis. And right away, this is a quick test to see if your belt has good tension. And I feel really good about this. So I'm gonna move on to the kind of better way to know, which is really briefly, you guys should have done this before, but basically you're just gonna run a quick Z calibration test. If you go down to calibration and then all the way down to calibrate Z, click that, and it's gonna ask you to scroll your knobs all the way up to the top. You guys should have done this by now. And then once you hit both at the top, click it. Are they all at the top? Yes. And now it's gonna run real quick. So the biggest thing to watch here is that as it goes from point to point, you wanna see if there's any slippage in the actual tension of the belt. And you also wanna check if there's too much tension. So if it's taking a lot longer, or maybe like a little bit of a grinding noise, that's not a grinding noise, that's just a very bad bearing. I worked on oiling that and that still doesn't work, so I'm just gonna replace the bearing. But you can see that it's moving very freely. There's no like slipping or sliding of the belt, and there's also no very like slow motion or kind of like a jerky. If it's tight, if the belt's too tight, it'll be more of a jerky motion. And you can see it's just flowing very smoothly. So it's just gonna finish up on these last 3 points in the back. I know it just tapped the back of the bed, but I gotta run an XYZ calibration for that. And you know, I had another tap, but that's okay. So it's gonna come back to the front, and then the last thing that I do just to make sure that, you know, the print went all right. And so the last thing that I do just to make sure that the, you know, x-axis fix that we just did went okay, I like to just double check one more time and see, okay, that's right there is the flat part of the motor shaft on my right, and you know, it's perfect. The screws perfectly align with it. So now your system knows that it's right at the zero. When it's moving anywhere in the x-axis, it's going to keep the same zero. So there's no issues with it slipping on the actual shaft and then printing in the wrong area because it's not using the correct zero to print. And if you guys did everything correctly that we talked about in this video, this is actually the part that I ran immediately after doing the changes that you guys just previously watched. You can see right off the bat that very good quality. There's no refraction anywhere. There's no x-axis shifting anywhere. Everything is very, very smooth and it looks great. So hopefully your guys' parts are looking like this. If it's not, you feel free to kind of rewatch the video, make sure you're doing everything right, or comment below and we'll make sure to help you guys out. All right, guys, and there you have it. There is how to do the x-axis shift fix. And I hope that this saved you some time. I know when I first did it, I ran into a few problems, but as long as you went through all that and everything worked out, should be good to go. If you have any questions, just comment below. And if this video helped you save some time, make sure you like and subscribe. Thanks for tuning in, guys.